Okay, so the next two word problems are both work word problems, where people are working together to do something. So we have a formula for this. As a reminder, that's 1 over the first person's time plus 1 over the second person's time. That's a plus. Equals 1 over the together time. Okay? So Ted can build a fence in 12 hours. If Maria and Ted work together, they can build the fence in 5 hours. How long would it take Maria to build the fence by herself? So we still need to define what x is, so I'm going to let x equal whatever we're trying to find, which in this case is Maria's time. Now we're going to set our equation. I know it's 1 over plus 1 over equals 1 over. Okay, so we have Ted, Maria, and together. So I'm just going to label some of these. We'll call the first one Ted, the second one Maria. The together is always going to be on the other side of the equal sign. Okay, so the Ted's time, that's 1 over 12, plus Maria's time. Well, that's the thing we don't know, so that's going to be 1 over x, equals 1 over the together time, which in this case is 5. Which makes sense. If they are working together, it should take them less time. A lot of times people get confused. They're like, well, how can they do it faster? Well, duh, with 2 people, this should be faster. I know sometimes when people say together, it should be more. Well, in this case, together should be less time because they're trying to do the work as fast as possible. So the LCD here between 12x and 5, they don't have anything in common, so basically you're just going to take each of them and multiply them, which gets 60x. I'm going to multiply 60x to every single numerator, and when I reduce 60 divided by 12, that's 5x. 60x divided by x, that x's divide out and you're just left with 60. And 60x divided by 5, that's 12x. Now I can solve by getting all of the x's on one side. So I have 60 equals 12x minus 5x, that's 7x. And then the last thing I can do is divide both sides by 7. And I get x equals 60/7. Now what was x to begin with? Oh, right, x was Maria's time. Good thing I wrote it down, right? So how long is it going to take her? It's going to take her 60/7 hours. Now you need to put hours, so I would accept 60/7 hours, although that's kind of weird. So another way you can think about that is 7 can fit into 68 whole times, because 8 times 7 is 56, with 4 leftovers. So this makes a little bit more sense. 8 and 4/7 hour. I know 4/7 is still kind of weird, but we're not going to bother changing it into minutes at this point. So a little over 8 hours, more like a little over 8.5 hours actually. So let's do this again. One painter can paint a room in 6 hours. Another painter can paint the same room in 8. How long would it take them to paint the room if they worked together? So what are we looking for? Let x equal their time when working together. So my equation is going to be 1 over plus 1 over equals 1 over. The first painter can do it in 6 hours. The second painter can do it in 8 hours. What if they work together? Well, I don't know the time. That's 1 over x. My LCD, when I'm trying to solve this, 6 times 8 times x would be a common denominator, but 8 and 6 have a common factor of 2, so the LCD between 6 and 8 is actually 24. 24 can be divided by 6, 24 can be divided by 8. If you used 48, that's fine. 24 is just a little bit smaller, which means our numbers are going to be smaller. So I'm going to go ahead and use the least common denominator. 24x divided by 6 is going to be 4. 24x divided by 8, that's 3. And 24x divided by x, the x's divide out, and you're just left with 24. Now this is a simple thing to solve. 7x equals 24. Divide both sides by 7. And I'm getting x is equal to 24/7. Again, 24/7 hour would be an acceptable answer, but to make it a little bit more sense here, 7 fits into 24 3 times with 3 leftovers. So 3 and 3/7 hour also would be acceptable. Either of these answers would work. So if one painter can paint it in 8, another one in 6, if they work together, clearly it should be less than 6, right? Because if the one painter can do it by himself in 6, it should take him less time if he had help. So 3 and 3/7 hour, that makes sense. At least it's less than what the other painter could do by himself. The next section we're getting into is the radicals. Now, some of these radicals have i's in them, some of them reduced to whole numbers, and some of them just reduced to other radicals. So I just kind of mixed them all up here. So in the first problem, we have the square root of -64. Now, whenever we have a square root of negative, that gets us an I. In this case, square root of 64 is just 8, so 8i. It's as simple as that. The next one, which should be problem 20, not 120, silly. The square root of 100 is 10. The next problem, the square root of 44. 44, that can be reduced. So let's see, that's 4 and 11, 2, 2 and 11. Root 100, you could have done it the same way. But like I knew that one by heart. Square root of 100 is just 10. Square root of 44, I don't know what the square root of 44 is, so then I have to work it out. In this case, the 2 comes out of the house. The root 11, he's single, he doesn't have a pair, so he has to stay inside the house. Now on this next one, I know I have an I. Anytime you have the square root of a negative, I know I have an I. But I have to do a little bit of work here. So what 75 is, that's 3/4, right? 75 cents. So 3 times 25. 5, 5, and 3. So the 5 goes out of the house. The negative comes out and becomes an I. And the only thing left is that single 3, and that is my final answer. Okay, so the next thing I can do is the cube root of 56. Now, because it says cube root, when I break it up, I'm looking for groups of 3, not groups of 2. So I've got, 7 times 8. 4 and 2. So that's 7, 2, 2, 2. Okay, so because I'm looking for a group of 3, the group of 3 2's come out, and the 7 stays home. One common mistake is students will drop that little cube root, and then it's wrong. 2 square roots of 7's isn't the same answer as 2 cube roots of 7's. So make sure you bring down the cube root. If the problem starts off to be a cube root, if you have a root left in it, it needs to be a cube root. Now, number 24, we have the cube root of a fraction, which seems really hard, but in this case, it's not that bad. We're just going to take the top over the bottom, which some of you might be thinking, oh, I have to rationalize. No, it's not even that difficult. The cube root of 125, that's just 5. That's one of those that you're supposed to memorize. The cube root of 8, that's 2, because 2 times 2 times 2 is 8. And that's it. You just take the cube root of the top and the cube root of the bottom. In this case, they were perfect, and it was pretty easy. Same thing here. We have the square root of 36 over the square root of 16. Both of those are perfect squares, so the square root of 36 is 6, the square root of 16 is 4, which reduces to 3/2. Again, they look hard, but they're not that bad. Now, number 26 is a rationalize. I can't reduce root 2, and I'm not allowed to have a root in the bottom. Remember, we're not allowed to have that. So what we're going to do is we are going to take the top and the bottom and multiply both the top and the bottom by root 2, which is in the bottom. Why do we do that? Well, because in the bottom, root 2 times root 2 is the square root of 4, and the square root of 4 breaks down to plain 2. So that makes us happy. We don't like to have radicals in the bottom. So this is a little process that makes the radical in the bottom go away. So I'm very happy, but I haven't done the top, so I gotta go back and do the top. 10 times root 2 is just 10 root 2. And now I can reduce. The 10 and the 2 are both outside the radical, so the things outside the radicals can reduce, and 10 divided by 2 is 5. So my final answer is 5 square roots of 2.